I just now turned on the microphone. So in the video, I just now turned, I still haven't figured out how to fix the website to put these on there. But anyway, I blame you. All right. But the Q's not trapped once I distribute. Okay. I've only got one Q term. There's the Q. Get that Q term by itself. Add 8A to both sides. How do I get Q by itself? Divide by A. And that's your answer. This is one of those things where subtract what? Because the A is multiplied times the parentheses, not added. I could make an argument that this is easier than regular algebra because there's almost no arithmetic to do. I won't make that argument because the fact that there's no arithmetic to do means that if you have several steps, by the time you get to the end, it's a complicated looking answer. All right, let's do a few more. Number 1 here says to solve for A. Now, this one's different than what we've done so far. It's still different, guys. Here's our equation. We're solving for A. There's not just one A written in the equation this time. There's 2. All right. Normally what we do is if there's an X on both sides of the equation and we're solving for X, normally we say, okay, we need to get all the X terms on one side. And we usually do that by adding or subtracting. Well, that's what I'm going to do now. Okay? I need to get all the A terms on one side. So all I did, well, you tell me, what did I do to both sides there? I added 8A. So 5A plus 8A is 13A. Bring down the plus C. On the other side, negative 8A plus 8A is 0. Now, I actually did some simplifying there, didn't I? I simplified 5A plus 8A and called it 13A. Now that I've done that, the rest of this equation works out like the other ones we've been doing. Subtract C from both sides. 13A equals negative C. And then what's the last step? You got it. So A equals negative C over 13. Which step are you at? At the very beginning, I could subtract 5A and turn that into C equals negative 13A, and then divide both sides by negative 13 from there. And I'd get C over negative 13 equals A. I could have done that. Number 2, solve for G. For G. All right, so I've only got a single G term. Yeah. Right there, right? That's the only G written in the equation. Get it by itself. What do I need to do to both sides? Subtract 2H, right? What's 7H minus 2H? 5H plus F equals G. Am I finished? By golly, I'm finished. I was solving for G. G is all by itself. There's nothing else to do. Number 3. Which variable are we solving for? We're solving for K. Take a guess. What should we do first? Multiply both sides by negative 7. Now, I wrote it out. You might not need to write it out, But the whole reason we're multiplying both sides by negative 7 is because negative 7 divided by negative 7 is 1. So the only thing left on the left side is k plus m. And on the right side, I can simplify that just a tad. N times negative 7, we would usually write that as negative 7n. A mistake that I make sometimes working these is I work a step or two, then I forget which variable I'm solving for. Solving for k. What do I do to get k by itself? Subtract m. And there's my answer. All right, number 4. What are we solving for? We're solving for p. That's actually r plus s. Is it r plus 5? Then s. Yeah, I know. Yeah, that's it. It's the one-stepper, isn't it? Get the p by itself by dividing by what's in the parentheses. Now, what did I do that I didn't write down? This. So it's kind of hard to make a judgment as to how difficult these problems are, because some of them are one step, some of them were 3 or 4, some of them you do a little bit of simplifying, some of them you do no simplifying. That's the way it goes. Questions so far? Okay. Let's take a look at this example 2 here at the top of this page. We're supposed to solve 3x minus 2y equals xz plus 5 for x. Well, we've got an x on each side of the equals. So look what I did. You tell me, what did I do first? I subtracted xz. That way, both of my x terms are on the same side now. But notice, unlike a problem we worked a few minutes ago, I can't simplify that and get a single x term. I can't add those or subtract those together. I can't do it. All right, so I'm still going to try to get all the x's on one side, everything else on the other. So I can I can add that 2y to both sides and turn my equation into this, correct? And this is what I've got so far. Now, what do you do when you have two terms with the variable you're solving for, two terms with x, and you can't add them or subtract them? Remember at one point in algebra, you factored out a greatest common factor? That's what we do here. The 3x and the negative xz both have a factor of x in them. So what I want to do is factor out that x. So I'm going to do x parentheses. It's the distributive property backwards is what it is. 3x, and I divide out an x, I must be left with 3. Negative xz, and I divide out an x, I must be left with negative z. See, like I said, that's the distributive property backwards. If I gave you that and said use the distributive property, wouldn't you come up with that? It's the distributive property backwards. But it did a huge, huge, huge service for us. How many z's are written in our equation now? Just one. Instead of having, or z's, x's. How many x's do we have? Just one. Instead of two x's, like we've had the entire problem, now we have a single letter x written down. What do? Divide. Divide by 3 minus z. So, There's not a single technique that you always use. You just have to look and see what you're faced with. I think I've worked every type of problem I need to. On this one, I get to combine the two D terms into a single D. On this one, I'm solving for Q. I have to do the factoring the Q out again. So take a look at each of those and see if those make sense to you. Any questions on either of those? And then I think that's everything there. All right, let's do this last one together. A hand soap company wants to use a cylindrical container to hold their new liquid soap. Use the formula for the volume of a cylinder. And we don't expect you to have that memorized anymore. It's volume equals pi r squared h, okay, for a cylinder. It says solve the formula for h. So I start with V equals pi r squared h. Look, there's only one h. How do I get rid of the pi r squared? Do I subtract? I divide. Divide both sides by pi r squared, and I have solved the formula for h. Now, why would I do that? Because what they give me then is they give me a volume to replace the V and a radius to replace the R. And that way, since I've already solved it for h, all I have to do is substitute those numbers in for those letters and simplify. I've already got it solved for h. So what is the height of a container? So what is h? If the volume is 56.52 cubic inches, so replace V with 56.52, and the radius is 1.5. So replace R with 1.5 squared. And you're going to want a calculator at this point, aren't you? Okay? So the 56.52 stays the same. When you square 1.5, you get, not 3, that'd be 1.5 times 2. You get 2.25. And still times pi, and then do the division. Now let me show you what to be careful of on your calculator. I want to divide 56.25. I want to divide that by 2.25 pi. But watch this. 2.25 pi. And not only do I not get the right answer, it's not even close. Because the way I typed it in the calculator, remember our order of operations that we spent several days on? But the calculator took 56.25 and divided it by 2.25, and then you know what it did with the pi? Multiplied it by pi. That's not what I meant. I can fix that with parentheses. 56.25 divided by parentheses 2.25 pi. Because my calculator knows order of operations. So what's the calculator going to do this time? It's going to work inside the parentheses and get a number for 2.25 times pi, and then it's going to divide 56.25 by that. That's what I want it to do. Now when I hit enter, I get that. So it turns out to be, I didn't even copy mine down right, did I? I wonder what I did that. Oh, anyway. Did it backwards, didn't I? 56.52 divided by parentheses 2.25 pi. So it's practically 8. Okay? All right. So I've got a worksheet for you.